Now let's see this question. This is given in GATE 2003. Let capital G be an arbitrary graph with n nodes and k components. If a vertex is removed from G, the number of components in the resultant graph must necessarily lie between k minus 1 and n minus 1. So this is not given. So options are not, these are not given, and we are supposed to find that out. Now they are asking us this: if a graph is initially having k components and n vertices, then if I delete one vertex from it, what is the least number of components possible and what is the highest number of components possible? That is what is asked, right? So now let us assume that these are not given. Now if you want to find out the least number of components possible, just think about one thing. By deleting a vertex, will the number of components reduce? It might reduce in one case. What is that case? If you assume that the entire graph is classified this way, that it is having all k components like this, out of which one component is having an isolated vertex. Now in case if you delete this isolated vertex, what happens is the number of components will drop down from k to k minus 1. Got it? Therefore this is the least number of components possible. Right? You cannot go lower than this. By deleting one vertex, you cannot reduce the number of components even further. So you can only reduce it by 1. Therefore k minus 1 is the least possible number. Now what is the highest possible number? See, when you have n vertices, and if you are going to delete one vertex, then the highest number of components possible with a graph containing n minus 1 vertices will never exceed n minus 1, right? Now let's see if there is a possibility through which we can get this number. See, I don't know this number, I am just guessing that since this is the maximum number of components that can be present in any graph having n minus 1 vertices, I want to see if there is this possibility is there if I delete one vertex. Now how is this possible is, you can imagine this way. Now assume that we have k components and all the components are like this. All of them are isolated, which means k minus 1 isolated vertices are there, right? So k minus 1 isolated vertices are there, and the remaining vertices, I don't know how many, are arranged in such a way that it is a star graph, right? Which means like this. Star graph is like this. I don't know how many there are, but all of them are connected by a central vertex. Are you getting this? K minus 1 vertices are isolated and there is one component which is present like this. Okay. Now how many components are there totally? K minus 1 plus 1, k components, and assume that the total number of vertices present in this is n. Now if I delete this particular vertex, the central one connecting this, right, then what happens? Then all the vertices will become isolated, and how many will be there? N minus 1 vertices will be there, because initially n vertices were there. Now this one will make n minus 1 components. Therefore by deleting a vertex, in worst case I might get n minus 1 components, and in best case I might get k minus 1 components. Got it? Which means this is the least number of components possible and this is the highest number of components possible. Definitely you cannot go beyond this. Why? With only n minus 1 vertices, you cannot have components more than n minus 1, right? And you cannot go lower than this. By deleting one vertex, you can only reduce the number of components by 1 in case if that is a isolated one, right? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.